Biomechanical analysis of the water polo penalty shot by college players. Water polo is played by two teams with 7 players each attempting to score goals through throwing the ball into the goal of the opposing team. The throws are the most crucial moves needed in a match because it defines the outcome of the match. And out of all the throws that is used in water polo, we chose to focus on the penalty shot. The purpose of this paper is to focus on performance improvement, and our goals are to analyze the shooting mechanics of competitive water polo players, discover the biomechanical variables affecting the said shooting mechanics and how it can be improved, to implement interventions in any form in order to improve the shot in all aspects, and to compare the shooting mechanics of the players pre and post intervention. For our participants, we use swimmers who have competitive experience in the sport of water polo, and we divided them into 2 groups of 5. One group to test the leg power and the body angles, and another group to test the force of the throw. Out of the 5 members per group, 2 will be assigned as the control subjects, while 3 will be in the experimental group. The variables to be observed are the throwing angles, height at which the ball was thrown, speed of the ball, force of the throw, and our constant variables are the distance of the players from the designated goal, which is 5 meters, and the target at which the players will aim for. We got the throwing angles by placing the camera 5 feet above the player, and the rotational angle was taken from the forward swing phase up to the end of the throw when the ball was released. We got the strength of the egg beater kick and the height at which the ball was thrown. We placed the camera 2 feet behind the player on a stable surface, and the maximum height of the ball before it was thrown was taken into account. We got the speed of the ball and the force of the throw by using a Bushnell radar gun for the speed, sensor kinetics accelerometer application for the acceleration, and we multiplied the mass of the ball by the acceleration to get the force. Um, the penalty shot was divided into 2 phases, namely the forward swing phase and the follow-through phase, in which we got the instantaneous acceleration along the z-axis for the forward swing phase and the instantaneous acceleration along the y-axis for the follow-through phase. These are the materials that we used for the study. So for our interventions, we focused more on speed and power, and we chose exercises that mimic the movement patterns of the actual penalty throw. So these are the exercises we gave to our players to improve on the force of the throw. Uh, for the leg power, we chose explosive exercises for the glutes, for the quads, and for the calves. And these are the exercises we gave to our subjects.
So for the results and discussion part, we first start off with the throwing power pre-test and post-test comparison. So the following tables are just the compilation of data of the trials of each player. So the players highlighted in blue, they're the control group, while the rest are the experimental group, meaning they underwent the strength and conditioning interventions which we provided and made for them. So this is the post test. Okay, so the first observation, if we use an intra-trial observation, we can see that the values of the acceleration z and force z are significantly greater than that of acceleration y and force y. So this means that the acceleration and force associated with the forward swing phase, since we got the force acceleration z and force z during the forward swing phase, is greater than that of the follow-through phase. So this is because the follow-through phase is actually a deceleration phase, because it has to do with the slowing down of the arm prior to the release of the ball, and the follow-through after which the ball is released. So what happens is that the contraction of the posterior deltoids, rhomboids, and trapezius, along with the muscles of the rotator cuff, they start to decelerate. Uh, they start to decelerate the arm prior to release. So this table here, it's the summary of the data. So it shows the mean of the mean averages of the force Z, force Y, and speed of the pre and post test per player. So again, the players highlighted in blue were the control players, control group players. So observations, we can see that all of the players had an improvement. All of their values went up during the post test. The thing that differed was the magnitude of this improvement, the difference of the difference. So we can see that the improvement of the experimental group was about twice that of the control group. So the control group improved by less than 1. There's a less than 1 deviation from the pretest, while the experimental group experienced a greater than 1, less than 2 deviation from the value of the pretest. So another thing we can observe here is the interrelatedness of the force Y and force Z with the speed. So if you can observe here this table, player 4 and 5, they have similar force Z, meaning they had similar acceleration Z. So they had a similar acceleration force during the forward swing phase. However, their speeds are significantly different as compared to the force Z, Y. So we can attribute that to their difference in force Y, which is the force and acceleration during the follow-through phase. So we can say that player 5 had a weaker follow-through phase as compared to player 4. So why does this happen? As I mentioned earlier, grip strength is important because I can say that player 5, what could have happened was that he was just simply pushing the ball. There was no flick of the wrist, and player 4 could have had the flick of the wrist associated with the follow-through phase. So the next thing we'll discuss are the body angles, specifically the rotation angle of the body from the preparation phase to the end of the shot. So this table shows the mean angle width of the pre-test and post-test along with the speed of the pre-test and post-test per player. So as stated, the angles were taken when the players were in the preparation phase of the shot. This is to see the complete rotation the players undergo when shooting. The intervention we actually made them do was to increase the rotation of the trunk and torso when shooting more than what was recorded during the pretest. So the results showed that the increase in rotation of the trunk and torso, which was derived from the increase of angle during the preparation phase, resulted in faster shots. So a good shot uses greater shoulder and hip rotation to throw the ball and not arm flexion and extension to throw the ball. Due to use of increased body rotation, players can create more power, making it easier to throw a penalty shot. The larger muscles of the trunk act first, producing trunk rotation in the direction of the throw, as well as trunk flexion forward during the throw. This trunk motion can also assist in producing ball velocity during the throw. So, similar to the previous test, all of the players experience improvement in the angle width and the speed, with the difference only being in the magnitude. So in the magnitude of the improvement. So these two images are examples of the few images we have of the throwing angle and how we measured it during the preparation phase. So lastly, we'll talk about the pre and post test results of the leg power. So the player's throwing arm length and height were taken into account in order to see the degree of improvement, if any, in relation to their respective heights, since a taller, longer-limbed player will naturally have an advantage in this test. Most of the results of the post-test were greater than that of the pre-test, with the exception of one player. However, that player was a controlled subject. Player 8 had the highest height. However, he was also the tallest and longest player. In terms of relative improvement, player 7 had the best result. If you compare his improvement in relation to his arm length and height. The height at which the ball is released is an indicator of leg power. As the shoulder rotates backwards to prepare for the throw, the egg beater kick increases in speed and helps to raise the body out of the water in preparation of the throw.
To know the significance of our study, we use the independent t-test. We input our data in a software called SPSS. We put our data like the mean and the significant difference, and it produced this table. We can see here in pair 1 that this is the comparison of the force in the y-axis of the pretest and the post-test, force in the z-axis, the speed in kilometers per hour, the height at which the ball was thrown, and the body angles. To know if the data is statistically significant, the level of significance must be greater than the p-value. The p-value is this column named sig2 table. Since we chose 0.05 as our level of significance, we can see that it is that everything is statistically significant except for the speed in kilometers per hour and the height at which the ball was thrown.
So for conclusion and recommendations, the number one is the entire cycle of the throwing motion is important and it contributes to the overall speed and force of the throw. So what coaches, skills coaches, strength and conditioning coaches, what coaches can do is that they can segment their training program based on the different phases of the water polo shot, not just one general shot motion, but since the different phases actually use different muscle groups, so you can adjust your training program in accordance to each phase of the shot. So segmentation.